Here at section 5.4 and 5.5, we're going to focus on rational functions. And our rational function is just basically over here in the upper right-hand corner of my graph, you can see is 1 over x. That's its basic format. And what's going to happen here is because of 1 over x, you're going to have what we call asymptote lines. Now, we know that when x is in the denominator, x cannot be equal to 0, so that's your y-axis. And you'll notice my blue graph doesn't touch the y-axis. This is a vertical asymptote line. An asymptote line is defined as the following. As x approaches a constant, in this case 0, both from the right and from the left as we head towards the origin, your y-coordinates must approach negative infinity or they go and approach positive infinity. Now, if we switch this around, horizontal asymptotes, what's going to happen is the c and the infinities, they get switched. And if you look on my graph, we don't touch the x-axis either. So here, as x approaches negative infinity or positive infinity, the y-coordinates approach a constant c. So what's happening here is now as, let's say we go out to positive infinity for my x's, 1 over 2, 1 over 4, 1 over 6, 1 over 8, 1 over 10, 1 over 100, 1 over 1,000, 1 over a million, I'm getting closer and closer to the value of 0. And if I do that on the negative side, 1 over negative 100, 1 over negative 1,000, I'm approaching 0 as well. It's just that I'm approaching it from the bottom side of 0 as opposed to the top side over here. The other oblique asymptote that we can have, it is somewhat related to the horizontal asymptote because the x approaches negative infinity and positive infinity. But now the y-coordinates approach some function q of x. And what we're going to look at is predominantly just what we call a slant asymptote. Oblique is kind of a whole catch-all for it. But we're going to be just 1 degree difference. So our slant asymptote is going to be another name for our q of x because it's going to be linear. We'll approach something like maybe an x plus 1, and we have a slanted, either going uphill or downhill. That's what we're going to call our slant asymptote. All right, so now let's go ahead and look at some graphs and do our transformation rules because we never really did transformations of rational functions in chapter 3. So when you graph f of x, 1 over x, you're going to look for these 6 beginning points. Here's 1, 1. 1 over 1 when x is 1. And then when x is 2, you'll have 1/2. So you put a 2 in for x, that's a half. You put a half in for x, you get a 2. 1 over a half is equal to 2. And then you'll have those in quadrant 1 and you'll have them in quadrant 3. And so the other thing I want you to quickly notice is that quadrant 1 and quadrant 3 graphs are identical. If I put my pencil on the origin and I turn my graph 180 degrees, it looks exactly the same, which means this graph is symmetrical to the origin. So if I want to take my 1 over x and then add a 3 after it, just like we talked about earlier, all these points are going to move up 3 squares. But what's really important here to understand is that your horizontal asymptote at y equals 0 is also going to move up to y equals 3. And there's your new graph. So it's almost like moving that x-axis up 3 squares and you get the exact same picture. So if I add 3, I subtract 3, shifting it up and down. Now notice in this next example, 1 over x minus 2, now the minus 2, or it could be plus 2, is inside the function because it's inside of the fraction. This is going to cause it to shift left and right like we talked about in chapter 3. So now your 6 points that you start off with are all going to go, remember, inside opposite of effect. It's going to go 2 to the right. X minus 2 set equal to 0. We would say x can't equal 2 because that's your vertical asymptote. So the x equals 0 is going to go to the right 2 squares, and then move your 6 points 2 squares to the right, and then there's your new rational graph. Now, the author will throw in an x squared. All that's doing is taking 1 over x and squaring it, which means you are not going to have any negative y's. What's going to happen is squaring all these negative x's is going to make them positive x's, but it's going to make it a little bigger. And so what I mean by that is if you square your x's, the power of 2, like I said, no negative y's. So what's going to happen now is between 0 and 1, right in here, it's going to increase much faster. All right? It's going to go up to that asymptote much faster. Or if you read it from left to right, it's going to decrease faster. And then from 1 to infinity, it's going to flatten out faster. So there is my new graph. So as you can see in my notation here, from 1 to 0, going to the left, it's going up a lot faster. Or if you will, decreases if you read it from left to right. And then it flattens out faster. And then you're going to get these same points over here in quadrant 2 because you have to have positive y's. So what the author will do is he'll say, okay, here's a new basic rational function. He'll call this the 1 over x squared rational function. So we'll come back to that in a minute. We'll do some transformations of that. Next example, 2 minus 1 over x. I prefer to have that 2 after the function because this reminds me this is my, if you will, d. That's where I add or I move up and down. Negative being multiplied to my x term here. All right, but it's on the outside. It's not in by the x. This is going to flip it over the x-axis. So these 3 points right here are going to flip over the x-axis. These 3 points here are going to flip over the x-axis. And there's the flip of the negative. Now, I agree with what you might be thinking. Well, could I put the negative on the x and flip it over the y? Sure. These 3 blue points could flip over the y and be these 3 red ones. These 3 blue points down here below the x-axis could flip over the y and be these 3 red. So basically putting the negative in front or on the x here is doing the same thing because our function is symmetrical to the origin. And then last, we'll take all of our red points, and we still have to shift those up 2 units, which means the y equals 0 horizontal asymptote line has to move up 2, and then we move up our 6 points and draw our graph. And there's where that graph is going to go. Next, there's my 1 over x squared. So now, like I said, the author's calling this a basic function. So here it is. And he wants to do a minus 2 to it, which means, okay, horizontal asymptote has to go down 2. All my points have to go down 2. So we'll just treat that new 1 over x squared as a basic function, and we'll do some transformations to it. Now, my next example here, if you don't like this problem, I'm all for it. I never expected to see it in the homework, but it does pop up every once in a while because there's like 10 problems per problem where you have to try a new one. So if you don't like this, count it wrong and try a similar question, and hopefully you don't get this ugly thing back. But what the author wants you to do is you got to turn it into 1 over x squared. So what you do is, because there's just one factor in the denominator, we manipulate it by writing it as 2 fractions. So x squared over x squared becomes a 1. And then we'll have minus 9 times 1 over x squared. Now, what's bad about this is multiplying by this 9 is going to do a vertical stretch. And because it's a negative 9, we got to flip it over the x-axis. And then when we're all done, then we have to move everything up by 1. So there's the negative 9. So that means you have to go to all your points and multiply your y coordinates by a negative 9. And then when you've done that, you shift them up 1. So what I'm going to do is I'm going to introduce, just to find some extra points to plot that will be easier to plot, is I'm going to look at when x is 3 and negative 3, right in this area here. So if I put 3 and negative 3 in here, that's 1/9 for both my y coordinates right there. That's 1/9 for the y, that's 1/9. So the reason I'm doing that is because I need some extra points. These 2 points right here, that's this y coordinate of 1 being multiplied by a negative 9, which makes it negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm way down here. No way in the world am I going to take that y coordinate of 4, multiply it by a negative 9, and try to graph negative 36 way down here. So that's why I need an extra point using x equals 3 and negative 3. So like I said, that 1/9 we can use and multiply that by 9, and that will be a 1. And this point right here, we said this was going to be, let's see, that was 1/4. Multiplying that by negative 9 makes it a negative 9/4. So that puts me at about negative 2 1/4, or negative 2.25. So those are those points. And then my other points will be right here at the negative 1, because that's 1/9 times a negative 9 for the y coordinate, moves it to negative 1. This is 1/9 for the y coordinate, multiplying it by negative 9 moves it to negative 1. Then we move them all up 1 square, including the y equals 0, and draw the graph. And as I said, yeah, this is kind of confusing. I get it. If you don't like it, get it wrong, and you'll get back to something like the previous problem where you just have to do maybe a shift up or down or left and right. But they threw this one in to be sneaky. And I've had students who take my class and they've never seen the problem, and I've had a student seen it twice. They got it wrong, tried to do a similar problem, got it another one, went ahead and got it wrong, and finally got something they didn't have to work with this ugly thing.